This is section 5.1, part 2. In this video, we are going to talk about the 2 rules of probability that are mentioned in section 5.1. There is a 3rd rule of probability, but we will talk about that when we get to a different section. All right, so let's move on to our rules of probability. There are 3 that we're really going to call the quote-unquote rules of probability, but we're only going to look at 2 of them in section 5.1. And our first one is going to be this idea of, I guess, the boundaries for what our probabilities could possibly be. What I usually do when I talk about this in class, like when I'm just doing my normal lecture over this section, I will talk about something like Memorial Day. And I might ask something like, what's the probability that Memorial Day is on Wednesday? So what would that probability be? Well, let me tell you what I get when I ask this. In the fall semester, I'll use Thanksgiving. In the spring semester, I usually use maybe Martin Luther King Jr. Day. For summer, I'll usually use Memorial Day or maybe Labor Day. But sometimes I'll get the answer 1 out of 7 because there's 7 days of the week. So there's a 1 in 7 chance that Memorial Day will be on a Wednesday. The problem with that is Memorial Day, just like Thanksgiving and Easter, Labor Day, Martin Luther King Jr. Day, Election Day, Veterans Day, Columbus Day. There's lots of holidays that we have that are set not as a specific date, like Valentine's Day is always February 14th, regardless of what day of the week that lands on. But all these other days that I've just listed, or all these other holidays that I've just listed, usually land on a Monday, but perhaps a Tuesday or a Thursday or something like that. But they all have a very specific day and a day of a week. And so the date might change. But Memorial Day, for example, will always be on a Monday. So the probability that Memorial Day is on a Wednesday, well, that's going to be 0. There is 0 chance that that's going to happen. That is impossible for Memorial Day to be on a Wednesday. And so we might say, all right, well, that's fine. We know it's on a Monday. So then if I ask you what's the probability that Memorial Day is on Monday, well, now that we've talked about that Memorial Day is on Monday, then that's always going to be true. And for something that is always true, the probability is going to be 1. And that's basically our range. We can never have something that's less likely to happen than impossible. I know that seems kind of weird to try and say it that way, but there's nothing that's less likely than that. And so there are no negative probabilities. Similarly, you can't have something that's more likely to happen than something that's certain or 100% chance going to happen. There's no numbers, no way to go above 1 or 100%. And so here's a scale that just kind of has a few words on it. We're actually going to do one that's a little more detailed on the next screen. But there we have something is certain if our probability is 1. Something is impossible if our probability is 0. Everything else is somewhere in between. And so in symbols, what we'll write, and this is how mathy people want to do it. We want to write it this way. We'll say that 0 less than or equal to the probability of some event, which is less than or equal to 1. And that basically just means that the probability, and if I highlight, so that probability is between 0 and 1. That's literally what those symbols translate to. So the probability of an event is going to be somewhere between 0 and 1. And then the fact that we have those lines underneath our inequality symbols means that they could also equal 0 and 1. So something is either impossible, cannot happen ever, probability of 0, or it's absolutely certain, has to happen, gonna happen no matter what, a probability of 1, or it's somewhere in between those two numbers. Now, also, just as a quick side note, of course, this could also be 0% and 100%. So sometimes we deal with the percentages, sometimes we deal with the decimals. So that 0 to 1 is when we're dealing with the decimals. Okay, so our video is already getting longer than I wanted it to, so I'm going to try and go a little bit quicker so I don't have to break this down into multiple videos for each section. But some of our words that we can use when we're talking about probabilities. So when we're somewhere between, of course, 0 would be impossible, and that's listed. But if we're somewhere between 0 and maybe even 20%, I might call that unlikely. Like if I hear there's a 20% chance of rain, I'm not going to worry about carrying my umbrella around with me everywhere. That's unlikely that it will rain to me. Or maybe even very unlikely. And I say that because I'm just now remembering that this next one is unlikely. Another word you might hear other than unlikely is improbable. So it's not impossible necessarily, but just not probable. And then very unlikely or highly improbable. That would be another one for I'm not going to take time to write that, but that would be another one for that smallest box there. And then this one that's kind of less than 50%, between 40 and 50%. And even though I know the words are going to come all the way to 0, but that's just so I have enough room to write, that's going to be less likely than not. And then, of course, we're just going to kind of go in the opposite direction. So instead of less likely than not, we're going to have more likely than not. That color doesn't look very well. It doesn't look very good, does it? Let me try just to use black on those darker grays. So more likely. Oops. I'm not doing a very good job writing. Likely than not. And then instead of unlikely or improbable, we're going to say it's likely. Or maybe just probable. I feel like I'm missing. Nope, that's right. I feel like there should be an extra syllable in there, but apparently I'm not. It's not. So more likely than not, likely, and then very likely. And of course, if we get, into this, you could even say almost certainly or nearly certain. And then when we get to 1, there we are at certain. So those are just some words that we can use to help us describe the likelihood of an event. All right, and then our second rule of probability that we're going to hit, again, there's one more, but we won't get to that until another section. But our second rule of probability says that the sum, and then again, we're going to do the symbols first, just so if you see it, you'll know what it is. The sum of all the probabilities should add up to 1. So the sum of the probabilities of all possible outcomes. That is one word. Let me fix that. Should equal 1. And the reason for this is because If we have all the possible outcomes, then that means that there's nothing left. If we added up all the probabilities that we have and we only get like 0.98, well, then that's a 0.02 chance of something happening. So we've missed one of the possible outcomes. So we want to be careful of that. We've got a table here, and this is a probability distribution where we're counting the number of dogs that someone has. So I house sit. This is not data that I've collected, but I house sit, and a lot of times there are dogs or cats, sometimes chickens. Once a bearded dragon. That was fun. But anyway, so the number of dogs that families have or people have. And, we've got that 25% of whoever the population was, whoever the group of people that they asked, 25% of them don't have a dog. Now, it doesn't mean they don't have a pet. This is specifically dogs. And 47% have one dog. 19% have 2, 5% have 3. That's me. I've got 3 German Shepherds, so I'm right there. Again, I'm not included in this data set, but that's where I would be. 2% of the people surveyed or asked or whatever had 4 dogs. 1% had 5, and 1% had 6. Now, the problem with this is, obviously, I know people who have more than 6 dogs, or I have known people who have more than 6 dogs. I had a friend who had 10 dogs at one point and finally kind of got rid of some because that was just too many for them. But anyway, I'm digressing. But there's probably more numbers out here somewhere, but of those who were asked, here's what we have. And if we add these numbers up, sure enough, when we stick these in the calculator, 25 plus 47, 19, 5, 2, 1, and 1, we get 100% or 1.00.